Well, hey everyone, and welcome back. You know, one of the worst things in life is just the fact that we can't always assume that something is what it really is just by looking at it. That sounds kind of weird, but you know, in many forms of science, we have apparent measurements for things, such as the apparent brightness of stars, or, particular to geology, apparent dip. Now, in my last video, I covered strike and dip, so if you need a refresher on what those are, feel free to check it out. Because in this video, we'll be talking about excuse me, apparent dip, which pertains particularly to dip and is very prevalent in the real world. Because when we have naturally occurring or man-made features such as cliffs, quarry faces, roads, and railroads running through geologic strata, the dip is often obscured because they don't run parallel to the dip. Think of it, dip is always measured from the horizontal, right? So if you have two surfaces, right, the horizontal, but then maybe another road surface or something that's running at a slightly different angle, it's hard to differentiate the two, and you may end up reading the wrong measurement because you assume the road to be the horizontal. So in many cases, we measure what is not actually the dip of a geological strata, and we measure instead the apparent dip. So apparent dip is anything between 0 degrees and the angle of actual dip on a strata. So if we've just got another generic block diagram, something that looks kind of like just another triangle. Something like that. If we know our true dip is this angle, alpha, then our apparent dip will be anywhere between 0 degrees, the horizontal, and the actual angle of dip. So that could be, I don't know, maybe something like up to there. And then when we look at our directional dip, that would look something like that. True dip, and the one on the left is the apparent dip. Now, you can find true dip from your apparent dip quite easily, or the angle of true dip, rather, but it requires topographic profiles and contour lines. So we're going to dive into a little example here. Let's just say we've got any generic surface, and we've got 3 contour lines here. And we'll say that they increment by 100 meters, why not? So this is 100 meters, this is 200 meters, and this is 300 meters. Okay, so let's say we're right off the bat given that this strike is, let's say that the strike is just north, okay? And of course, strike can be determined. There's really, in no cases will there be an apparent strike. Strike is just a cardinal direction, so it should be easy enough to determine just by looking at a bed of strata. So this is easy enough to just give or find yourself in a problem like this. But if we know that our strike is to the north, well, you recall that the dip is always perpendicular to the strike, so the dip in this case would be going to the west, I believe. It's not the end of the world if I don't get that correct. You can check me with the right-hand rule if you wish. But let's just say, for the sake of simplicity, we know that the dip is dipping in this direction, because we know it's always perpendicular in direction to the strike. Okay, so we know the direction of the true dip, but let's say the apparent dip is measured to be slightly different, right? maybe it's measured in this direction. Okay, easy enough. So we get these two arrows with a common origin, and both extending in different directions. Now, here's where we do some actual measurement on the topographic profile itself.